Right, today's lesson is looking at probabilities from histograms and bar charts. Um, Generally, there's two types of charts. You either have the frequency charts, which counts the number of things that are being counted, or you have a probability chart that will have the probability in the same. Remember, the only difference between frequency and probability is that probability is worked out by taking the frequency and dividing it by the probability. So generally, probability charts and frequency charts look the same. So if we take a look here, here's an example of a distribution of New Zealand students, and they're separated in which school they're in. So you can get a lot of information from distribution. You see quite clearly that primary schools are around about that 450,000. And that's much higher than secondary schools, which are about 290,000, which makes a lot of sense because in primary schools, generally they go up to year 8 or year 6, whereas in high schools we have only year 9 through to year 13. The other thing is there tends to be a drop-off in the senior part of the school as well, so it would make sense that it's smaller. So if we change this to a probability question, if I randomly chose a student, it's more likely that they'd be a primary school student than a secondary school student. Or we also have composite schools, which is about 50,000, and a special school, which is about 2,000. So if we're quickly just doing some maths, it kind of looks like you're about 9 times more likely to be at a primary school than a composite school, and you are about just over half more likely to be in a primary school than a secondary school. Okay, another distribution here. We have the distribution of schools by gender, and it's quite clear to see if I randomly selected a secondary school, New Zealand secondary school student, they are overwhelmingly going to be more likely to come from a co-ed school than a single-sex boys or a single-sex girls school. So you can see the majority of people are in co-ed schools. This one here is interesting. For adults convicted in court receiving or handling the proceeds of crime in New Zealand, you can see, so these are the, for people who are convicted, what their sentence is. So you can see most likely is community work, which is imprisonment is second. So it seems to be, there's a few other things there where there's home detention and stuff like that. But you can see if I randomly chose criminal who's been convicted for having the proceeds of stolen goods, they are going to get more likely to get community work. However, the next most likely option is that they get imprisoned. The next one here is births registered with the 50 most popular boys' names in 2017. So you can see there that the most popular or the most likely is Oliver, followed by Jack, Noah, William, and so on. A surprise with Arlo, and there's some other names in there. If your name's not on there, it doesn't mean that it's a bad name. It just means that it wasn't used that much in 2017. But we can use this to predict what some of the most likely names are. So, how do we relate this all to probability and the calculations we're going to make? So you can use this, and this is an example of the long run frequency that we talked about in last lesson. So this graph here is the probabilities of, or the relative frequencies that people took of a piece of writing and how many of each letter there is. So the question is, if I choose a letter at random, what is the probability it would be the letter C? All right, so then it's just a case of reading straight off the graph. We can see C is here, and that measures off at 0.03. So the answer then C is equal to 0.03. Now a vowel, what's the probability if I chose a letter at random off a piece of writing? What is the probability that it's a vowel? So that's probability of A, E, I, O, U. So we can take a look at those probabilities. So you can see A is 0, 0, 0.08. E, we're looking at 0.13. I, we're looking at 0.07. O, looking at 0.08. And U, we are looking at 0.03. So with our calculation, we're going to go 0.08 plus 0.13 plus 0.07 plus 0.08 plus 0.03. Get out the calculator. I'm adding those probabilities together from the calculator, we get 0.39. The last question we've got is probability that if you selected one from random, that it would be a letter A through to W. So we could go through and find all the probabilities of each one of those letters, they're A through to W, and add them together. What is a much easier way is just to take the probabilities of X, Y. So the probability of A through to W is the probability, same as the probability that it's not X, Y, or Z. And I've put a little dash there to signify with the notation that it means not X, Y, or Z. So the probability that it's not X, Y, or Z is 1, take away the probability of X, Y, and Z, which in this case is 0.02. We'll just ignore the probabilities of X and Z because they're so small, which gives us the answer 0.98. Right, that's that one. So, last question. So this is a distribution of 100 students and how they mode of transport they use to get to school. So the question we've got is, if I chose a student at random, what is the probability the mode of transport to school would be by bus? So we'll notice that this distribution is slightly different, that it's frequency rather than probability. Now you have a choice. You could change the graph so that it's a probability question, and the easiest way to do that is simply take the axis and divide the scale by how many people there are in total. In this case, it's 100. So we could take 10 divided by 100, 20 divided by 100, and so on. That would mean that this would be 0.1, 0.2, 0.3, 0.4, And then you could read the probabilities as 0.29. We could then use 0.15. The probability of the car is 0.35. And the bus is 0.18. And the train 0.03. And then use that quite quickly, work out probability of bus is equal to 0.18. For the next question, I'll show you how to do it using just the frequency. It's exactly the same thing, but rather than dividing at the start, you divide at the end. Okay, you can see it's now been restored as the frequency, so we no longer have the probability. So question 2, if I chose a student at random, what's the probability that the mode of transport would be under their own power, so walking or cycling? So the probability of walk or cycle. Now, first things is it's out of 100. So because I'm using frequency, I still have to divide by the total number of people that we've used. You can see that walking is 29 and cycling is 15, which means we end up with 44 out of 100, which is 0.44. So that's it. So either using a probability graph or a frequency graph and to get their probabilities. There's obviously some pages out of your workbook or a worksheet for you to complete. So make a start on that.